Hello my beautiful PU2 aspirants, I know your exam is knocking your door. So in this particular moment, I am here with full physical chemistry. So here in this one video, all doubts in physical chemistry is going to be sorted. So all probable question, maybe it's MCQ, maybe it's theoretical 2-3 marker, or maybe it's a numerical based question. I am going to give the answer here itself and the derivation as well. So make sure you are watching the full video, and expected from these questions only you are going to get the question in your upcoming examination. So these questions are precisely have been chosen from the model papers, from the question bank, and by judging all the trends in the previous year questions. So make sure that you are not missing a single point out of it. So yes, to get to know the detailed answers of the most important question, watch till end. So a lot of things I have to tell, a lot of question we need to discuss. So yes, without further delay, let's get started with the first chapter, because only 3 chapters are there in your physical chemistry, that is solution, chemical kinetics and electrochemistry. Only these 3 chapters will be covered in this video. Okay, so let's start with the solution chapter. Here comes the entire formula chart for the solution chapter. You can take a screenshot or whatever you wish, you can make a note of it. Only in these formulas you are going to get the numerical or maybe theoretical questions. Okay, so okay, first we will discuss the 1 marker questions. So here you can see which of the following statement is false. Okay, so the relative lowering of vapor pressure of solution is equal to the mole fraction of the solution, mole fraction of the solute present in the solution. So definitely that's going to be correct. Next, passage of solute molecule towards the solution side through semi-permeable membrane is osmosis. That's going to be the wrong one, because we know what is your osmosis. Your osmosis is basically passage of the solvent molecule, not solute molecule. So that's going to be the false option. Next, here you can see molar solubility of helium, nitrogen and oxygen are plotted against partial pressure of the gas at constant temperature. Henry's law constant for these gases will lie in the following sequence. Okay, so here you can see, if you just remember the Henry's law, that is P equals to partial pressure equals to kH into mole fraction, right? So now if you want to plot a graph, okay, kH plus 0, okay, so there is 0 intercept, so graph will be something like this with slope kH, right? So here your y-axis should be P and x-axis should be mole fraction or solubility, right? But here you just see one thing, solubility and partial pressure, they are just interchanging the axis as well, right? So if you follow this, partial pressure versus mole fraction, then in accordance to KH, it should be first O2, then N2, then HE, right? But here what they are saying, they are just interchanging the axis, right? Interchanging the axis. So what you have to take? You have to take 1 by KH order, right? So that's the reason first will come helium, then it will be N2, then it will be O2. Okay, so in accordance to that, you can see option B is going to be the correct one. Okay, let's proceed further. Pi 1, pi 2, pi 3, pi 4 are the osmotic pressures of 5% solution of urea, fructose, sucrose and potassium oxide respectively at certain temperature. The correct order of their magnitude. Okay, so for this particular case, what do you have to do? What is the formula? Pi equals to CRT. C can be written as N by V RT, right? So volume, R, T, everything is quite similar. Everything is similar for all the solution, right? Because volume 5% means 100 ml, right? But 5% means 5 gram of each solute, they will represent different number of moles. So we have to calculate the N for each cases to understand the trend of pi. the trend of osmotic pressure. So let's calculate. So first we will calculate for number of moles of urea. Okay, so 5% they said means 5 gram, and molecular weight of urea is 60. So if you calculate this, 0.0833. Okay, so number of moles of fructose, if you calculate, 5% they said, and molecular weight of fructose is how much? 180. Okay, so here you should get something 0.028, I guess. Okay, so number of moles of sucrose, again 5 divided by 342, right? So if you calculate, you should get something 0.01, right? Next, number of moles of, okay, one more thing I just want to tell you, this is not KO, this is basically KCl. Okay, if you just check the original question, it's basically KCl. So we are going to do this with respect to KCl only. So KCl, it's going to be 5 divided by KCl is 74.5. One more thing that 74.5. One more thing that we have to do here, we have to multiply this KCl, this number of moles with 2. Why? Because urea, for urea, it cannot be dissociated. Fructose cannot be dissociated. Sucrose cannot be dissociated. But KCl can be dissociated in K plus and Cl minus. So whenever it will come to the solution, it will be of 2 particular ions, K plus and Cl minus. So you have to multiply this with 2. So 10 by 74.5. So here also you are going to get something 0.1. Okay, so in accordance to that, if you see, your order is going to be something, this is maximum, right? Pi 4, then it comes this one, right? Means pi 1, right? Then it comes this pi 2, then it comes pi 3. Okay, so your answer is going to be C. I guess this is clear to you. Let's proceed. The mixture which shows positive deviation from Raoult's law. So this type of question we did multiple times, even in the live session, last live session we discussed this type of thing. So for this case we have to check positive deviation, right? AB interaction is weaker. Okay, so the answer is going to be B, ethanol and acetone, because individual ethanol is having strong hydrogen bond and acetone is having dipole-dipole interaction, right? So whenever they are mixed together, then AB interaction will be weak. Let's proceed. Okay, so if you are preparing for your KCET examination as well, then our Deeksha Karnataka channel already had launched ABHYAS KCET test series. It is providing 35 mock tests in it. So yes, to boost up your preparation level, make sure that you're enrolling yourself in this particular test series, because that's really gonna helpful. Along with that, one bonus thing that you are getting, it's KC30 batch launched by Deeksha Karnataka. So here, in case you are having very little time, right, and if you want a proper structured schedule for your KCET preparation with the expert guidance, then KC30 is going to be the most beneficial for you, because it is going to give you the 30 days live online crash course. You will get your expert faculties every day for the doubt solving. You will get complete coverage of PU1 and PU2 syllabus. Mock test will be there, test format PYQs will be also there, and you will get it only in 2499 if and only if you take it by 25th February, but later on the price may vary. Okay, so make sure that you are taking the full advantage of this particular series. Enroll yourself today to get top 1000 rank in KCET. Yes, so let's proceed further. Okay, concentration terms like mass percentage, ppm, mole fraction and molarity do not depend upon temperature. However, molarity is a function of temperature, because in the denominator portion you are having the volume unit, right? So your answer will be, let's check, volume depends on temperature. Yes, option A. Let's proceed further. Assertion reason type of question. Molecular mass of benzoic acid when determined by the colligative properties is found high. Reason, dimerization of the benzoic acid in solution. Yes, absolutely, because benzoic acid with the hydrogen bond, intermolecular hydrogen bond, it dimerizes. As a result of this, let's say 2 units of benzoic acid, they get merged. So definitely the molecular weight, the effective molecular weight will be higher than that of the initial one. So both are correct, right? Your answer is going to be both assertion and reason is true, and the reason is the correct explanation of the assertion, option A. Okay, let's proceed further. The mole fraction of the solvent is 0.9, the relative lowering of vapor pressure. So relative lowering of vapor pressure is basically delta P by P naught equals to mole fraction of the solute, right? Mole fraction of the solute. So if solvent is given as 0.9, then solute is basically 1 minus 0.9, that's going to be 0.1. So that is going to be the relative lowering of vapor pressure. Okay, let's proceed. Dissolution of calcium chloride in water is exothermic process, while that of ammonium nitrate is endothermic process. The observation is, okay, so solubility of calcium chloride decreases with increase in temperature. Okay, so here you can see calcium chloride, whenever you are dissolving, it's an exothermic, means after being dissolved it is releasing some heat. So now at the very beginning, if you rise the temperature, so dissolution process will be lesser in accordance to the Le Chatelier principle, right? So definitely the solubility of calcium chloride will be decreasing, okay, with increase in temperature. Okay, now ammonium chloride is endothermic, it's temperature required process, right? You need temperature. Now if you increase the temperature for ammonium chloride, dissolution will be better. Okay, so option A is going to be the correct one. Okay, I guess it's clear up to this. Let's proceed further. When acetone and chloroform are mixed together, which of the following observation is correct? So whenever acetone and chloroform they are mixed, you can see, let me just show it to you, intermolecular hydrogen bonding will be there. Chloroform hydrogen and acetone oxygen, they will create some hydrogen bonding, and as a result of this the interaction becomes very strong. Okay, so AB interaction will be stronger than that of the individual AA and BB interaction. So what is the answer? AA and BB interactions are weaker than that of the AB interaction. Option B is going to be the correct one. I guess it's clear. Let's proceed. Okay, so it's a general question. What is molarity? How does it vary with temperature? How does it vary with temperature? What is molarity? That I don't have to tell. The number of moles of solute that is present in 1 liter of the solution, that is a molarity. How does it vary with temperature? So molarity, if you write, then number of moles of solute divided by volume, right? Volume of the solution. Now volume and temperature, if you see, volume and temperature, they are directly proportional, right? So for that perspective, molarity and temperature, they are inversely proportional, right? Because molarity and volume, they are inversely proportional. So molarity and temperature, they are also inversely proportional. Okay, so what is the SI unit? Okay, what is the SI unit? Mole per liter. Mole per liter. Okay, let's proceed further. 3-marker question we are entering. Application of Henry's law to prepare definitely carbonated beverages. There are application of Henry's law, and scuba divers, right? Scuba divers, they faces bends when they go deep down to the ocean, right? Because of the dissolution of nitrogen gas in the blood. But now to prevent this, they actually mix helium in some certain amount of helium they are mixing to prevent the bend. That can be well explained using the Henry's law. Next is anoxia. Anoxia is something that the higher altitude people they used to face because of the lesser amount of oxygen in low pressure. In the higher altitude they actually get, and brain doesn't get enough supply of oxygen, hence they get some dizziness, this type of thing, okay, nausea, because of the lesser oxygen in the brain, right? So that can be well explained using the Henry's law. It's clear, I guess. Let's proceed further. It's from the solubility, state Henry's law, write its mathematical form. So I don't have to tell it differently, you can directly write this statement that the solubility of gas in a liquid is directly proportional to the partial pressure of the gas. Okay, mathematical form you can write P equals to KH into X. Make sure that you are writing the abbreviation correctly. Okay, next, what is the significance of Henry's constant? So KH, what is the significance of KH? KH actually gives the solubility of a gas at a given pressure. Okay, so higher the KH value, it indicates lower the solubility because they are inversely proportional, right? Let's proceed. Okay, the question is derive its mathematical expression of vapor pressure for a solution of a non-volatile solute in a volatile solvent. Okay, so let's do it. We know pressure of a solution is directly proportional to the mole fraction of the solvent because solute is non-volatile, right? So from there I can write pressure of the solution is basically equals to K, any constant, into mole fraction of solvent. Okay, so if I take K equals to P naught, so in that case it should be PS equals to P naught into mole fraction of the solvent, right? Okay, now what we can write, delta P. What is delta P? Delta P is basically equals to P naught minus PS, right? So now here what we are going to do, let's say this is my equation number 1. From equation 1 I am going to put the value of PS here. So delta P equals to P naught minus P naught of mole fraction of solvent. Okay, just replacing the PS here. Okay, so now what I can do, I can take P naught as a common, so P naught into 1 minus mole fraction of solvent, right? From there if I continue, then it should be delta P equals to P naught. See, 1 minus mole fraction of solvent will give you the mole fraction of solute, right? Mole fraction of solute, right? So now from here what I can do, delta P by P naught is basically mole fraction of solute. Okay, so from here I can write P naught minus PS divided by P naught is basically equals to mole fraction of solute. So that is nothing but the relative lowering of vapor pressure. Okay, so this is what they are asking to derive you. Okay, I guess it's clear. Let's proceed further. Okay, so now they are asking draw a suitable labeled diagram to express the relationship for ideal solution of A and B between vapor pressure and mole fraction of the component at constant temperature. Basically they are asking to draw the diagram that is for the ideal solution in accordance to the Raoult's law. Okay, so here you can see vapor pressure versus mole fraction like this. If you join this intercept you will get the total pressure. Okay, that's it. Let's proceed. Here you can see ideal solution, right? So ideal solution for this case it will be equal to P naught A of XA and delta H mix it should be equals to 0 and delta V mix it should be equals to 0. Okay, non-ideal solution with positive deviation, so total pressure should be positive, right? More. So P naught A of XA, delta H mix should be positive and delta V mix should be positive as well. Okay, non-ideal solution with negative deviation it should be this P naught of A x A delta H mix should be negative and delta V mix should be negative as well. Okay, I guess it's clear. Let's proceed further. Give the difference between ideal and non-ideal solution. I guess you can do it. It obeys Raoult's law. It doesn't obey Raoult's law. Delta H, delta Vx, you can make V mix. You can mention. About interaction, you can mention. For ideal solution, the interactions are same even after mixing. But in non-ideal solution, the interaction after mixing changes. Let's proceed. Okay, differentiate between the types of non-ideal solution. One is positive deviation, another one is negative deviation. So, along with the example, you can take any 3 or any 2 in accordance to the marks, because it is a 3-marker question. You can take 3, okay, and you can go ahead. So, yeah, let's proceed. Differentiate between maximum and minimum boiling azeotrope. So, maximum boiling azeotrope shows negative deviation of Raoult's law, and minimum boiling azeotrope, they shows positive deviation of Raoult's law. Now, for this case, for maximum boiling azeotrope, they boil at higher temperature than that of the usual boiling temperature of each component, right? And for minimum boiling azeotrope, they boil at low temperature than that of the each component expected boiling point. Example you can mention. Okay, let's pause it. Colligative properties, you can show, you can see, show that the relative lowering of vapor pressure for a solution is equals to the mole fraction of the solute when solvent alone is volatile. Already we did the derivation, you can just check out from here as well, or that derivation is also okay. Proceed further. Okay, show graphically how the vapor pressure of a solvent and a solution of a non-volatile solute change with temperature. Show on this graph the boiling points of the solvent and the solution, which is higher, and give reason. Okay, so for this case, this is nothing but the elevation in boiling point graph. So basically what happens whenever you are putting non-volatile solute in volatile solvent, there occurs elevation in boiling point. So usually in normal case you can see the solvent was boiling at this temperature TB0, you can see, but after the solute being added, it will boil at TB. Okay, and this particular difference is basically called as delta TB. Okay, so this is the entire thing. So boiling point basically increases. So elevation of boiling point, it is something that we observe here. Okay, I guess it's clear. Let's proceed further. What is semi-permeable membrane? Give an example of each for natural and synthetic semi-permeable membrane. So semi-permeable membrane is a membrane that allows only the solvent molecule very selectively, okay, to pass through it during the osmosis process. Okay, and example natural, you can take the example of animal bladder, and for the synthetic you can take cellophane paper, right? Let's proceed. Explain the desalination of water by reverse osmosis. Name the semi-permeable membrane used in it. So reverse osmosis is basically used in desalination of water. What actually we do here, in the salt water we give the pressure more than that of the osmotic pressure. As a result of this, solvent from the high concentration zone through the semi-permeable membrane, it comes to the fresh water zone where the concentration is low, okay, and we collect the pure water. Okay, so this is basically the reverse osmosis process that we use in the desalination mechanism. Okay, and here the membrane that we use, that is cellulose acetate. Okay, let's proceed. Okay, abnormal molecular mass. Why do electrolytes show abnormal molecular masses? Name the factors responsible for the abnormality. So basically they shows abnormal molecular masses because of two things: association or dissociation. Okay, so the factors responsible, definitely at first let me just discuss about the association. So sometimes what happens, because of the intermolecular hydrogen bonding, two molecule they gets attached. Let's say dimerization of benzoic acid, right? So because of the hydrogen bonding only. So this is the association. Okay, so as a result of this, colligative properties will be observed. Then dissociation. Let's say I am taking one salt that will be dissociated, let's say aluminium sulfate, KCl, they will be dissociated into ions, right? So as a result of this, you can see more number of particles will be there. Okay, so molecular mass will be lower because they are dissociating into ions. I guess it's clear to you. Let's proceed. Okay, based on their nature of the compounds, assume that the compound will undergo either 100% association or 100% dissociation. Compare these compounds with your Van 't Hoff factor value. Okay, let's proceed. What we have to do here, we just have to break them in ions. So for K2SO4, 2K plus SO4, 2 minus. How many ions? Count. Total 2 plus 1, 3. Right? So here I am getting 3, means 6. Okay. For NaCl if you break down, that's going to be Na plus Cl minus, it's going to be 2. Right? FeCl3, if you break down, same number of ions you will get for the K3 FeCl6 as well. So that's going to be Fe3 plus 3Cl minus. So how many ions you are getting? You are getting 4 ions out of it. So aluminium sulfate, let's break down for this case. 2Al3 plus 3SO4, 2 minus. How many ions? For this case you are getting 5 ions. Acetic acid and benzene, they will dimerize. Okay, so for dimerization we will get half. I'm directly writing it, we will get half. Urea and glucose, they will not dissociate, hence 1. Okay, so let me just point it properly. This is going to be 6, this is going to be 2, right, means 3. This is going to be 4. Okay, this is going to be 2, and this is going to be 1, this is going to be 5. Okay, I guess this is clear now. Let's proceed further. Okay, give reason. This is reason based question from the solubility. First, aquatic animals are more comfortable in cold water than that of in warm water. What the reason behind it is, in cold water, because if you see the relation between temperature and solubility, they are inversely proportional. If you decrease the temperature, solubility will increase. So in cold water there will be more dissolved oxygen, and that is more beneficial for the aquatic animal. They will survive in a better way, right? This is the first case. Next, liquid ammonia bottle first cooled in ice before opening it. So basically what happens, ammonia in high pressure at room temperature, what happens, it is having high pressure at room temperature, right? Ammonia, they are having high pressure because it's very volatile, right? So if you cool it down, then what happens, the vapor pressure reduces, right? If the vapor pressure reduces, then whenever you are just opening the knob, it prevents the sudden exposure of ammonia gas. Okay, sudden escape of the ammonia gas. Okay, that's it. Next, dissolution of some solid compounds is exothermic, while that of some other is endothermic. It is basically, in case you are having hydration energy greater than that of the lattice energy, then your process is exothermic, and if your hydration energy is less than that of the lattice energy, your process will be endothermic. That's it. Okay, so it is completely dependent upon the relative magnitude of the lattice enthalpy. Okay, lattice enthalpy and hydration enthalpy. Okay, I guess it's clear to you. Let's proceed. Okay, next question, the vapor pressure of a liquid is constant at constant temperature. So why? Because the vapor pressure, definitely it's constant at the constant temperature. Vapor pressure is constant of a liquid is constant at constant temperature. Why? Because an equilibrium is established in that temperature. Okay, so the rate of evaporation from the surface itself, from the surface of a liquid, evaporation takes place of that particular liquid, right? So rate of evaporation becomes equals to the rate of condensation. The rate in which it is going to the vapor phase, in the same rate it is coming back to the liquid phase at a particular temperature. That's the reason it is constant. Next, the vapor pressure of a solution of a non-volatile solute in a given solvent is less than that of a pure solvent. Okay, so what basically happening, whenever a non-volatile solute you are adding in a solvent, volatile solvent, then the non-volatile solute molecule, they gets accommodated on the surface area of the solvent. Okay, so vaporization takes place from the surface, right? If the surface is blocked by the non-volatile solute, then how it will come out? How it will get evaporated? Not possible. So as a result of this, vapor pressure decreases. Okay, vapor pressure is less, right, than that of the pure solvent. I guess it's clear. Let's proceed. Okay, an increase in temperature observed on mixing chloroform with acetone. So what basically happens? Definitely because of the hydrogen bond that will form. Okay, so intermolecular hydrogen bond forms in between the acetone oxygen and chloroform hydrogen that releases some sort of it. As a result of this, you will see some exothermic reaction. Okay, next, mixture of ethanol and acetone shows positive deviation from Raoult's law. So ethanol individually it is having the hydrogen bonding, intermolecular hydrogen bonding, and acetone is having dipole-dipole interaction, right? So now what you are doing, you are mixing ethanol and acetone. So in between two ethanol molecule where hydrogen bonding was taking place, now acetone is coming in between, right? So hydrogen bonding will be disturbed, completely disturbed, right? So this is basically AB interaction, means ethanol and acetone interaction is weak. That is nothing but the positive deviation. Okay, next, pure ethyl chloride cannot be obtained from rectified spirit even by fractional distillation, because in this particular percentage, that 95.4% alcohol, in this particular percentage when they are present with water, then it forms the azeotropic mixture. Okay, and azeotropic mixtures cannot be separated using the fractional distillation method because they boils at the same temperature. Okay, let's proceed. Okay, ocean do not freeze, okay, because a large amount of salt, it is actually dissolved in the sea water. Because of that, the freezing point of water decreases a lot. Okay, as a result of this, it usually doesn't freeze. Okay, next, water stops boiling when sugar is added to boiling water. So again the same reason, if sugar is added, then it increases the boiling point of the water, elevation in boiling point takes place, right? So that's the reason that solution boils, means sugar water solution, it boils at higher temperature. Okay, next, the freezing point of a solvent is lowered on dissolving a non-volatile solute in it. Again the same thing, the freezing point is lowered when any kind of non-volatile solute is added to it, just because the vapor pressure decreases. Okay, like as the vapor pressure decreases, the equilibrium between the solid and liquid, that is achieved in lower temperature, right? So that is called the freezing point depression, right? So that we observe as a colligative property. I guess it's clear to you. You can see the answer from here as well. Let's proceed. Okay, while making ice cream in metal or plastic cones, the ice cream seller puts a mixture of ice and common salt around the cones and not ice alone. Okay, what's the reason behind it? Okay, so again the same thing, just to lower the freezing point. Okay, whenever you are mixing a non-volatile solute, that is your salt, okay, so the freezing point, okay, will decrease, right, depression of freezing point, right? So as a result of this, it will be colder than that of the 0 degree Celsius. The ice will be colder than that of the mixture, not ice, the mixture of that salt and water, it will be colder than that of the 0 degree Celsius, right? So that's the reason. Next, when fruit and vegetables that are dried are placed in water, they slowly swell and return to the original form. This is just because of the osmosis, okay, through the semi-permeable membrane, the solution enters into that particular thing, that's why. Next, cutting onion taken from the fridge is more comfortable than cutting onion lying at room temperature. I would rather do that. Why? Because why it is more comfortable? Because it reduces the volatility of the chemicals, because the temperature is low, right? The temperature is low. As a result of this, the volatility of the chemicals that is present over there, majorly sulfur, okay, that causes the eye irritation. So they reduces the volatility. As a result of this, you will not get eye irritation. Okay, let's proceed. This is a diagram based question. For this graph, answer the following questions. What type of non-ideal solution shows such behavior? You can see this is this dotted line represents the ideal behavior. As you can see, it's towards a positive end. You can say it's a positive deviation. And next, give example for such type of non-ideal solution. Ethanol and acetone, you can take the example. Next, what type of azeotrope will the mixture of A and B form? So this is basically the positive deviation of Raoult's law. They will show minimum boiling azeotrope, right? Let's proceed. What is azeotropic mixture? Give example. What are the different types of azeotropic mixture? Explain with example. What are difference between minimum boiling azeotropes and maximum boiling azeotropes? Fine. So what are azeotropic mixture? They are basically the mixture of two or more substituents. They boils at a constant temperature. And one more thing that you can also mention, they have same composition in the liquid and the vapor phase as well. Okay, so you can take the example of the nitric acid and water, 68% nitric acid and 32% water. In that percentage ratio only, they will make the azeotrope. And next question was different type of mixture. Okay, different type, you can take the maximum boiling azeotrope and minimum boiling azeotrope. Now what are the difference between minimum boiling azeotrope and maximum boiling azeotrope? That you can take, we already gave this over there. The difference, you can take that it will show minimum, negative deviation in Raoult's law. Another one is positive deviation in Raoult's law. And when in which temperature they boils, we can give the example. Already we have discussed. Okay, next. Okay, so let's proceed further. Fine, we will proceed with the numerical problem now. Here you can see the first question. Calculate the mole fraction of benzene and carbon tetrachloride in a solution made by dissolving 20 gram of benzene in 80 gram of carbon tetrachloride. Okay, let's do it. So number of moles of benzene, let's calculate at first. So number of moles of C6H6, let's calculate. So that's going to be 20 divided by 78. So almost it will come up to be something like 0.25, I guess. Okay, next, number of moles of CCl4. If I calculate this, it should come up to be 80 divided by molecular weight of CCl4 is 154. From here what I can get is 0.51, I guess. Okay, so now from here if I calculate the mole fraction of C6H6, so from here how I should do it, that is 0.25 divided by 0.25 plus 0.51, right? So if you calculate this, your answer will come up to be something like 0.33. Okay, and similarly mole fraction of CCl4, if you calculate 1 minus 0.33, that's going to be 0.67. Okay, I guess this is clear. It's directly, you just have to find out the mole fraction. Okay, let's proceed. The mole fraction of helium in a saturated solution at 20 degree Celsius is given. Find the pressure of helium, the solution of the above solution. Henry's constant is given. Okay, so here pressure of helium, it is basically what we can do is KH into X, right? Okay, so here you can see this is the Henry's law. So Henry's constant, Kh into mole fraction of helium, right? So simply we can do it, 144.97 into 1.2 into 10 power minus 6. Okay, so from here if you calculate further, you will get 1.74 into 10 power minus 4. This. Further if you convert, it should be 0.174 bar only. Okay, that's it. I guess it's clear. Let's proceed further. The boiling point of benzene, this is a very important question actually. The boiling point of benzene is 353.23 Kelvin when 1.80 gram of a non-volatile, non-ionizable solute was dissolved in 90 gram of benzene. The boiling point raised to 354.11 Kelvin. Calculate the molar mass of the solute. Okay, so this is also a direct formula you can apply, that is elevation of boiling point. At first delta TB let me calculate, that is TB minus TB naught, right? So TB is given as 354.11 minus 353.23 Kelvin, right? So if you do this, it should come up to be 0.88 Kelvin, right? Now if you just put the formula, delta TB is basically equals to I into KB into M. Now further if you do, I value will be 1 because benzene is non-ionizable, right? So if I write KB, from this I can get weight of the solute divided by molecular weight of the solute into weight of the solvent into 1000, right? So from there your M2 will come up to be something like KB into W2 into 1000 divided by delta TB into W1. Okay, so now what I will do, I will just substitute the value here. So if I substitute, M2 is going to be delta TB we are getting as okay, KB at first 2.53 into weight, how much it is given, 1.80 into 1000 divided by 0.88 into 90 gram, right? So now if you calculate this, your answer will be 57.5 gram per mole. Okay, I guess it's clear to you. Let's proceed further. Okay, let's proceed. 1 gram of non-electrolyte solute dissolved in 50 gram of benzene lowered the freezing point of benzene by 0.4 Kelvin. Find the molar mass of the solute. So again the same approach we will proceed with. So delta TF is basically equals to KF into M, right? From there M2 we can write in the same way. Again you can see this is a non-electrolyte, so I value will be 1, right? So it should be KF into W2 into 1000 divided by delta TF into W1, right? So now if you put the thing, that is 5.12 into 1 gram into 1000 divided by 0.4 into 50. So if you calculate this, your answer will come. Okay, this is 256 gram per mole. Okay, I guess this is clear to you. Let's proceed. Okay, so we should proceed with some model paper questions. Let's start. Here you can see 10 ml of a liquid A and 20 ml of a liquid B are mixed at 25 degrees Celsius. The volume of a solution was measured to be 30.1 ml. So 20 plus 10, if you add them, it should be 30 ml, right? But here you can see they are getting 30.1, means delta V mix is greater than 0, right? Delta V mix is greater than 0. From there you can conclude that it is basically the positive deviation of Raoult's law, right? Positive deviation of Raoult's law. In case you are having positive deviation of Raoult's law, from here you can mention delta H mix, that is also positive, right? So in accordance to that, option C is the correct one. Okay, I guess this is clear. Let's proceed. A student took 2 glasses of pure water from a water filter. He cools glass A in fridge and warms the other glass B on a stove. On comparing the solubility of oxygen in H2 in glass A and glass B, he stated that glass A contains, okay, so as the temperature of A lowers, right? What we know, temperature is inversely proportional to that of the solubility. So if you decrease the temperature, solubility of oxygen will increase. So that is the reason glass A will contain more oxygen than that of B. So option A is going to be the correct one. Let's proceed. Here you can see if on mixing 2 liquids the solution becomes hot, it implies that it shows negative deviation from Raoult's law. So yes, if it implies an if it is hot, means it is an exothermic, right? And exothermic indicates delta H mix value negative. So if delta H mix value is negative, that will give you negative deviation, right? So yes, statement 1 is correct. Statement 2, solution which show negative deviation are accompanied by decrease in volume. So if it is negative deviation, definitely delta V mix is also going to be negative, right? So both the statements are true, right? Option A is going to be the correct one. Let's proceed. The mixture which shows positive deviation, so this thing I discussed multiple times, ethanol and acetone. Let's proceed. A binary solution has 2 components A and B. The mole fraction of component A is 0.5, then the number of moles of component A and B in the solution. So if mole fraction of one component is 0.5, another component will be 0.5 as well, because the summation will be always 1. So as a result of this, number of moles will be similar as well. So option C is going to be the correct one. Let's proceed. The mass percentage of glucose in water 10%. It means 10 gram of glucose present in 100 gram of solution. 100 gram of solution means what is the amount of solvent then? 100 minus 10, that is 90 gram. So 90 gram of water, 10 gram of glucose dissolved in 90 gram of water. Option D is the correct one. Next, here you can see it's a diagram based question. Given below is the sketch of a plant for carrying out the process. Name the process. That is a reverse osmosis, definitely, or better to say it is a desalination of water. Okay, name the process occurring in the given plant, means what's going on inside the plant. It's actually reverse osmosis is going on, right? Now name any one SPM, means semi permeable membrane, which can be used in this plant. We can use cellulose acetate for the desalination. So reverse osmosis in bracket you can write desalination as well. Okay, one practical use already it is given as a question, so desalination of seawater you can mention. Okay, I guess it's clear. Let's proceed. Okay, name the concentration term which is commonly used in medicine and pharmacy. Write the definition and mathematical equation for the concentration term. So weight by volume percentage, this is something that we used for the pharmaceutical purpose. So how we should do it? Weight by volume percentage can be defined as weight of solute present in total volume total volume of solution into 100. Okay, that's it. I guess it's clear. Let's proceed further. Write the reasons to justify the osmotic pressure method. Osmotic pressure method has the advantage over the other colligative methods for the measurement of the molar mass and macromolecules. So here comes three different reasons. You can see high sensitivity of the macromolecules. Okay, so as you can see, large molecules like protein, polymer, like whenever other colligative property like boiling point you are varying, freezing point you are varying, it's very difficult to measure the change at that particular variation of temperature because they are very much sensitive. Okay, because you need very dilute solution. Okay, means that's the reason in osmotic pressure method you can do the molar mass method, you can find out the molar mass in very diluted solution. So you can proceed with the osmotic pressure method. Next is room temperature measurement preserves the molecule. Sometimes in high temperature or low temperature, as you are varying the temperature, they can denature, right? They can break down, right? So that's the reason osmotic pressure method is more applicable because it can be done in the room temperature. Next, use of molarity, simplify the calculation. Okay, I guess this thing is clear to you. Let's proceed further. Okay, here comes a few questions. Numerical problem we will discuss, that is from the model papers. Okay, first question, Henry's constant for the molarity of methane in benzene at 298 Kelvin is given. Okay, calculate the mole fraction of methane in benzene at 298 under 760 mm of Hg. Fine. So let's proceed. At first we will see what is given to us. Okay, so let's proceed with the problem. So partial pressure of CH4 is basically equals to KH into mole fraction of CH4. Mole fraction of CH4 is something that we have to calculate, right? So that is basically equals to pressure of CH4 divided by KH. Okay, now simply just put the value. Pressure of CH4, it's definitely going to be 760 mm of Hg. Okay, divided by what is KH here, 4.27 into 10 power 5 mm of Hg. Okay, so if you calculate this, your answer will come up to be something 0.00178, that is the mole fraction of methane. Okay, I guess this is clear to you. Let's proceed further. Calculate the osmotic pressure in Pascal exerted by a solution prepared by dissolving 0.925 gram of polymer of molar mass this in 500 ml of water at 37 degrees Celsius. Okay, fine. Let's proceed. Here at first, see, pi equals to CRT. Osmotic pressure you have to find out. So this formula I need. So C I can write it in the form of N by V, right? N by V into RT. So I need to find out the N, right? So N is going to be equals to, see how much amount is given, 0.925 divided by 18500 gram. Okay, one more zero is there, gram per mole. We will do the calculation later. Okay, so pi is going to be, let's write all together everything, 0.925 gram divided by 18500 gram per mole. Okay, into how much volume is given, 500 ml. Okay, let's convert it into liter. If you convert it into liter, it should be 0.5 liter, right? It should be 0.5 liter. Fine. Next, here we will put the value of R, that is 8.314 into 10 cube Pascal liter Kelvin inverse. okay, into T is basically 37 degrees Celsius. 37 degrees Celsius we have to convert it into Kelvin. So it will come up to be something 310 Kelvin. Everything here will be cancelled out. If you calculate this, your answer will come up to be something like 25.77 Pascal. Okay, so this is the answer. I guess you understood this. Let's proceed. Okay, so here you can see if solution obeys Raoult's law for all concentration, its vapor pressure would vary linearly from 0 to vapor pressure of pure solvent as shown in graph. Calculate the value of X. Okay, fine. So how I should calculate? It's very easy basically. P equals to P naught of solvent into mole fraction of solvent, right? So from here what I can do is, X value is this, right? This is my X, okay, vapor pressure, right? So this is going to be P naught will be how much? This is for the vapor pressure. In a normal case it should be atmospheric pressure, right? 1.013 bar, okay, into X value we can put from the graph itself, that is 0.4. Okay, so if you calculate this, it should come .4052 bar. That's it. This is your answer. Okay, so here the main thing is you just have to write down this atmospheric pressure by yourself. Otherwise it's a very simple numerical. Okay, I guess this is clear to you. Let's proceed further. Okay, calculate the mass of a non-volatile solute which should be dissolved in 114 gram octane to reduce its vapor pressure to 80%. Okay, let's do it. First, molecular weight of octane, if I do it, C8H18, right? So from here if I calculate 8 into 12 plus 18 into 1, so 114 I will get, right? 114 gram per mole. That is a molecular weight. Next, number of moles, let's calculate given weight by molecular weight. So 114 gram is also given, divided by 114 gram per mole, right? So from here I am getting 1 mole, right? So now what I have to do, relative lowering of vapor pressure formula I can apply. PS by P naught is equals to mole fraction, right? So as you can see, they are saying 80%, right? 80% of the pure solvent, right? It reduces its vapor pressure to 80%. So from here I can write P naught equals to 80% means, sorry, not P naught equals to, PS we can calculate, that is 80% of P naught, right? So from here 0.8 of P naught, that I can replace here, that is 0.8 of P naught divided by P naught equals to X2. Okay, so now if you just calculate X2 from this case, let me just simplify for you people. P naught I will cancel out. Okay, X2 will come as 0.2, right? 1 minus 0.8, that is 0.2. I guess up to this step it is clear to you. Okay, now we can calculate the number of moles. How? Because mole fraction X2 is going to be N2 divided by N1 plus N2, right? X2 we know that is 0.2 and N2 we have to find out, right? N2 divided by what is N1, that is 1 mole, right? Plus N2, we have to calculate N2, right? So 0.2 into 1 plus N2 will be equals to N2. From there, if you further calculate 0.2 plus 0.2 into N2 equals to N2, okay. From here, if I do it, if it goes there, 0.8 of N2 will be equals to 0.2. From here, N2 value will come up to be something 0.25 mole. Okay. So now 0.25 mole, number of moles we got. Now easily we can get the weight, right? Mass we have to find out, right? So weight, how I should find out? That is weight equals to number of moles into molecular weight, right? Number of moles is how much? 0.25 into molecular weight is given as 40. So if you just calculate, it will come up to be something 10 gram. That is the answer. I guess you understood. First, we calculate the number of moles that we replaced in the relative lowering of vapor pressure formula. From the relative lowering of vapor pressure, we got the mole fraction of the non-volatile solute. From the mole fraction, we got the number of moles of non-volatile solute, right? From the number of moles, we calculated the mass of the non-volatile solute. I guess this is clear. Let's proceed further. Here you can see, calculate the osmotic pressure of 0.5% weight by volume aqueous solution of sucrose at 300 Kelvin, and R value is given, molecular weight of sucrose is also given. So first we will calculate the number of moles, okay. Number of moles is basically 0.5. See, 0.5% weight by volume, by default it is saying 5 gram, I mean 0.5 gram of sucrose is present, right. So 0.5 divided by 342 gram per mole. This is gram. So if you calculate this, it will give you something almost equals to 0.00146 mole. Okay. So now volume, you can see volume by default I am having 100 ml, right, means 0.1 liter. Okay. Now let's proceed with the formula, that is pi equals to N by V into RT. So N value is given, that you know, 0.00146 divided by 0.1 into R value is given here 0.0083 liter bar mole inverse, and temperature, that is 300 Kelvin, right, 300 Kelvin. Okay. So if you calculate this entire thing, your answer will come up to be something like 0.036384 bar, right. Okay. So yeah, I guess this is clear to you. Let's proceed further. Okay, so here is the end of the solution chapter. I guess whatever the question we covered, it will be more than enough for you. Okay, because we have covered a little bit PYQ, question bank questions and model paper. Okay, so yeah, that will be more than enough for the solution chapter. And for the MCQ part, please refer the all MCQ video that I already uploaded. Okay, let's proceed with the electrochemistry chapter. Okay, so first question, first we will recapitulate at first. So you can see E cell formula, E cathode minus E anode. This is the Nernst equation. Okay, this is the delta G and Nernst equation, I mean E0 cell relation. This is delta G and equilibrium constant relation. This is E0 cell and equilibrium constant relation. Okay, here comes the different terminologies along with their definitions and units. It's very important. Okay, just with a glance, just revise. Next, Faraday's law, this is the formula. Second law, this is the formula. resistance, that is a formula, resistivity, cell constant, conductance, conductivity, molar conductance. Okay, that's enough. This much formula you have to remember to proceed with the chapter. Okay, first question, the reaction which is taking place in nickel cadmium battery can be represented by which of the following reaction? So basically here cadmium gets converted to cadmium hydroxide and nickel oxide gets converted to nickel hydroxide. So option A will be the correct one. Let's proceed further. Which of the following statement is correct regarding the variation of molar conductivity with concentration? So for this case, molar conductivity, always remember, it increases with decrease in concentration. If you dilute this, molar conductivity increases, because molar conductivity, if you see the formula, the concentration terms comes below, right? Kappa into 1000 by C, lambda m equals to kappa into 1000 by C. So they are inversely proportional, right? So if you increase the concentration, molar conductivity will be decreasing and the vice versa. So option C is going to be the correct one. Let's proceed. A galvanic cell has electrical potential of 1.1 volt. If an opposing potential of 1.1 volt is applied to this cell, what will happen to the cell reaction and the current flowing through the cell? So if same amount of current, opposing current, if you apply over there, the reaction will stop and there will be no current flow. So just check for the option. Option A itself, it's a correct one. I guess it's clear. Okay. Next, which of the following is not correct? Let's see. The metallic conduction is due to the movement of electrons in the metal. That's true. The electrolytic conduction is due to the movement of the ions. That is also true. The current carrying the ions are not necessarily discharged at the electrodes. That is also true. Next, the metallic conduction increases with increase in temperature, whereas that of electrolytic conduction decreases with temperature. No, electrolytic conduction also increases with the increase in temperature. If temperature you increase, what happens? The kinetic energy for both the electron and ions, it increases. That will increase the conductivity. So option D is the wrong one, not correct. Okay, let's proceed. The variation of lambda m of acetic acid with the root of concentration is represented by this one. Okay, acetic acid is a weak electrolyte, right? So the variation is something like lambda m versus root C. I guess you remember this. It is something like this, right, for weak electrolyte. Let's proceed further. Okay, it is from the electrochemical cell. 3-marker question. What is the role of salt bridge in connecting anode and cathode or two half cell? So first, it maintains the electrical neutrality both the sides. It prevents the accumulation of charges in the half cell and it prevents the liquid-liquid junction potential formation. Okay, let's proceed. What is a salt bridge? And next question, what happens when a salt bridge is removed? Next, why KCl is used in the preparation of salt bridge? So here you can see salt bridge is basically a U-shaped glass tube that is filled with a agar-agar gel that contains different salt like KCl, KNO3, NH4NO3, this type of thing. Okay, this is salt bridge. Next question. What happens to the cell if it is removed, right? So if the salt bridge is removed, then there will be no current flow, hence potential will drop to the zero because the circuit is not yet completed, right? Next, why KCl is used? KCl is used because we choose those salt for those cases the cations and anions have the they have the same type of mobility or they have same velocity, okay, or sometimes we call it as transport number. Okay, they have almost same transport number. That's the reason we choose this type of salts. Okay, let's proceed. what is the standard cell potential of a Daniell cell? That is definitely 1.1 volt. Next, write the Hoff cell reaction occurs in the Daniell cell. So anode reaction and cathode reaction that we can write. So here you can see, if I write that, it's already given here. Okay, so Zn will be converted to Zn2 plus and 2 electron. That 2 electron will be taken by Cu2 plus and it will be converted to Cu. So overall, if you just see overall cell reaction, Zn plus Cu2 plus will be converted to Zn2 plus plus Cu. That is the overall cell reaction. Okay, I guess it is clear to you. Next, what happens the cell potential when concentration of cathodic solution increases. So if the concentration increases of the cathodic solution, cell potential also increases. Okay, next, mention the direction of the current flow when the electrons are moving from anode to cathode during the working of galvanic cell. So if current moves from anode to cathode, if current moves from anode to cathode, definitely the flow of electron will be opposite to that of the electron flow. Okay, so they are saying that electrons are moving from anode to cathode, right? Electrons are moving from anode to cathode, so current will be moving from cathode to anode, like that. Okay, let's proceed. Write the symbolic notation of the Daniell cell. So here comes the symbolic notation. You can see Zn will be converted to Zn2 plus, it will be oxidized, and this is the salt bridge. Then Cu2 plus from the solution will be converted to Cu. That's it. Let's proceed. Okay, so let's proceed with the next problem. Here you can see a solution of CuSO4 is electrolyzed for 10 minutes with a current of 1.5 amperes. What is the mass of copper deposited at the cathode? Atomic mass of copper is given. Fine. So we can use Q equals to I into T. Q equals to I into T to find out the charge. So 1.5 ampere it is mentioned into 600 second, right? So that will give you 900 coulomb, right? So now Cu2 plus will take 2 electron and it will be converted to Cu. So number of moles of electron, if I want to find out, that is charge divided by Faraday. So 900 coulomb divided by 96500 coulomb per mole. Right, from here I will get 0.00932 mole. Okay, so now number of moles of Cu I have to find out, right? Number of moles of copper if I find out. So if 1 mole of Cu2 plus require 2 mole of electrons, so number of moles of Cu must be 0.00932 divided by 2. Okay, it should be 0.00464 mole. Okay, now from here I can find out the mass of copper. So that is basically 0.00464 mole into molecular weight, that is 63.5. Okay, if you calculate this, your answer will come as 0.2938 gram. Okay, I guess this is clear to you. Let's proceed further. How much electricity in terms of Faraday is required to produce 20 gram of calcium from molten calcium chloride? Fine. So calcium first, number 1, calcium 2 plus in molten, it will takes up 2 electron to give you calcium, right? So number of moles of calcium we can calculate. 20 gram is given, that is divided by 40 gram, that is the molecular weight of calcium, is going to be 0.5 mole. Okay, so number of moles of electron is going to be 0.5 into 2, that is 1 mole. So what is the charge of 1 mole of electron? That's going to be 1 Faraday. That is the answer. Okay, so 1 Faraday you need. Next, number 2. I am having Al2O3, means Al3 plus, right? So Al3 plus 3 electron will give you aluminium, right? From here, number of moles of aluminium, again in the same way we will do. 40 gram is given, divided by 27. Okay, so if you do it, you will get something like 1.48. Okay, so now simply number of moles of electron in the same way you can calculate 1.4815, sorry, what I'm writing, 1.48 into 3 electron, right? So from here you will get something 4.44 Faraday. Okay, I guess this is clear to you. Let's proceed. Here we will discuss some model paper question. Okay, let's proceed with the model paper questions. Okay, first question, a cell that converts energy of combustion of fuels like hydrogen and methane directly into electrical energy, that is basically fuel cell. Next, among the following cells, the cell used in Apollo space station, H2O2 fuel cell. Next, write the overall reaction of the nickel cadmium battery. Here you can see this is the anode reaction, cathode reaction and overall cell reaction. Okay. Next question, here you can see the cell is the cell in which the reaction occurs. Okay, let me just write it down for you. 2Fe3 plus 2I minus will give you 2Fe2 plus I2. This is the reaction. E0 value is given. Calculate log Kc. Fine. Let's do it. We can use directly the formula. E0 cell is basically equals to 0.0591 by n into log Kc, right? So from here E0 cell I can calculate 0.236 equals to 0.0591 divided by 2 into log Kc, right? So from there log Kc you can just calculate. Okay, your answer will come up to be something like 7.986. Okay, I guess this is clear to you. Let's proceed. Calculate the limiting molar conductivity of Cl- ion by using the data lambda of calcium 2 plus and lambda m0 of CaCl2. Fine. So cold rush law we are going to apply here. So we know lambda m0 of CaCl2 is going to be lambda 0 of Ca2 plus 2 into lambda 0 of Cl minus, right? For this case, lambda 0 of Cl minus is going to be lambda m0 of CaCl2 minus lambda 0 of Ca2 plus divided by 2. So that's going to be, just put the value 271.6 minus 119 divided by 2. Your answer is going to be something 76.3 Simon centimeter square mole inverse. I guess this is clear. Let's proceed. Okay, the limiting molar conductivity of CH3COH is given. Using the graph, given information, calculate the limiting molar conductivity of CH3COOK. Okay, so from the graph I can get the limiting molar conductivity of KCl and HCl from the intercept, right? So limiting molar conductivity of HCl, if I want to find out, it will be the intercept, that is 425 Simon centimeter square mole inverse, right? Now for the lambda m0 for KCl, that is also given. So that is basically in between 125 and 175. So I can take 150 Simon centimeter square mole inverse, right? So now what I can do, I can directly proceed with the formula, not formula, if I just break down. So lambda 0 of CH3COOK, that can be written as lambda 0 of CH3COOH plus lambda 0 of KCl minus lambda 0 of HCl, right? So this is how we can represent this. So now what we have to do, we can just put the value over there. So that is 390 plus KCl value is 150 minus 425. Okay, so your answer will be something 115 Simon centimeter square per mole. I guess this is clear to you. Let's proceed. Okay, mention 3 factors which decide the products of electrolysis. This thing we already discussed in the last few slides. You can just go through once. Proceed. What are the electrochemical cells? Name 2 types of cell, galvanic cell and electrolytic cell. Okay, proceed. One more numerical problem. A column containing 0.05 molar NaOH has an area of cross section 0.785 centimeter square. The length of 1 meter shows a resistance of 1.11 into 10 power 14 ohm. Calculate the molar conductivity of the solution. Okay, let's do it. So here see, concentration is given, right? A is given as 0.785 centimeter square. I will convert it into meter square. So 0.785 into 10 power minus 4 meter square. Right, now let's calculate G star, cell constant. It is L by A, so 1 meter by 0.785 into 10 power minus 4 meter square. Okay, if you calculate this, it will come up to be something like 12740 meter inverse. Okay, so once you have the G star, you can calculate the kappa from here. If I want to calculate kappa, kappa is basically equals to G star by R. Okay, so G star value is 12740 meter inverse divided by 1.11 into 10 power 4 ohm. Right, so from here if you calculate, kappa will come up to be something like 1.148 Siemens per meter. Right, now what do you have to calculate? Molar conductivity, right? So lambda m is basically is going to be kappa by C into 1000. Right, just put the value over here, 1.148 into 1000 divided by 0.05. Okay, so if you just calculate this, your answer will come up to be something like 0.02296 Siemens meter square per mole. Okay, I guess this is all right. You understood this. This is step number 1. You have to calculate the G star. Using G star, calculate kappa. Using kappa, calculate the molar conductivity. Okay, let's proceed further. Okay, for this case, what you have to do? Calculate the electromotive force of the cell. Assume the cell reaction at 25 degrees Celsius with the reaction this. Okay, we can simply use Nernst equation out of it. So E cell equals to E0 cell minus 0.059 divided by N log Cu2 plus by Ag plus whole square, right? So let's put the value 2.97 minus 0.059, here number of electron exchange is 2, log, let's put the value 0.25, sorry, 0.25 divided by 10 power minus 3 whole square means 10 power minus 6. Okay, so if you just calculate this, I'm not going to the detailed calculation of it. I'm just directly telling you the answer. You can calculate log nicely. So 2.811, wait, yes, 2.811 is going to be the answer. Okay, I guess this is clear. Simple Nernst equation application. Okay, let's proceed. Okay, we will proceed with the chemical kinetics now. So yeah, this is the first question we will solve with the initial rate method. Okay, one problem we will solve, probably more problem will come related to the initial rate method. I will try to avoid them because I will show the first one. In the similar way, you can proceed with the calculation of the next numericals if it comes. Okay. Okay, let's proceed with the numerical. First, write the general rate equation for this. R equals to K into A power X into B power Y, right? So now for this case, first rate is given as 6.0 into 10 power minus 3 equals to K into A value is given as 0.1 power x into 0.1 power y. This is equation number 1. Next equation is 7.2 into 10 power minus 2 equals to k into 0.2 power x into 0.3 power y. This is equation number 2. Next is 2.4 into 10 power minus 2 equals to k into 0.1 power x into 0.4 power y. Next is 2.88 into 10 power minus 1 equals to k into 0.4 power x into 0.3 power y. Okay, this is your equation number 3. This is equation number 4. Okay, so what I am going to do is I am doing equation 3 divided by 1. Okay, so you have to choose such a term so that similar term gets cancelled out and you can get at least common term for the x or for y. Okay, so I am doing 3 by 1. So yeah, let's do 2.4 into 10 power minus 2 divided by 6.0 into 10 power minus 3 equals to k into 0.1 power x into 0.4 power y divided by k into 0.1 power x into 0.1 power y. Okay, so if you calculate this further, it will come up to be 4 equals to 4 power y. From here you can write y equals to 1. Okay, now what I can do is, I can do 4 divided by 3, sorry 4 divided by 2 I can do, 4 divided by 2. So from there I will get 2.88 into 10 power minus 1, sorry, divided by 7.2 into 10 power minus 2 equals to k into 0.4 power x into 0.3 power y divided by k into 0.2 power x into 0.3 power y. From here you will get 2 square equals to 2 power x and hence x equals to 2. This is something you will get. So a power 2, b power 1. Option C is going to be the correct one. I guess this is clear to you. Let's proceed. Okay, for the reaction H2 plus I2 will give 2HI. Draw the diagram showing the plot of potential energy versus reaction coordinate to the to explain the role of activated complex in the reaction. So here you can see H2 plus I2, they will react and they have to cross the activation energy barrier. At the top of the peak, you will see the activated complex is generated where it is neither the reactant nor the product. That is called transition state. After crossing the activated complex, it will come up to be the product. Let's proceed. Mention 3 factors that affect the rate of a chemical reaction. So these are the factors. You can see, you can take concentration, temperature or catalyst. Proceed. Okay, one more numerical. The first order rate constant at 600 Kelvin is 2 into 10 power minus 5 and the energy of activation is 209.8 kilojoule per mole. Okay, calculate the rate constant at 700. So Arrhenius equation you have to use here. Let's proceed. So log K2 by K1 equals to EA by 2.303 R into T1 into T2. So T2 minus T1 here. Okay, so let's proceed. K2 you have to find out, K1 we can put from the question itself, that is 2 into 10 power minus 5, right? Equals to EA value, you can see it's given in kilojoule per mole. We will convert it to joule. So 209,800 joule per mole divided by 2.303 into 8.314 in 8.314 joule per mole per Kelvin, right, into T1 and T2 value if I put here 600 into 700, here 700 minus 600, 1 by K. So everything will be cancelled out here, you can see. So log K2 by 2 into 10 power minus 5 is going to be something 209,800 divided by 2.303 into 8.314 into 100 by 421,234. Okay, this is the thing you will get. So on being simplified, you will get something like this. This side if you calculate completely, you will get log K2 by 2 into 10 power minus 5, you will get this side 2.6. Further if I calculate, I will do anti-log. K2 by 2 into 10 power minus 5 equals to 10 power 2.6. Okay, so now what we can do is K2 equals to 2 into 10 power minus 5 into 10 power 2.6. So if you just calculate this, it will come up to be something like 8.1 into 10 power minus 3 second inverse. Okay, I guess this is clear. Okay, the full calculation I showed here, I guess it's clear for you. Let's proceed. Okay, this is a MCQ based question, very important question from the model paper. The reaction 2NH3 gives N2 plus 3H2. The rate is going to be a zero order reaction. Why? Because the dissociation of the gas or decomposition of the gas is going on a metal surface. Let's proceed. Write two differences between order and molecularity. Here you can see so many differences are there. Any two you can pick and you can write it down. Let's proceed. What is meant by chemical kinetics? Give any two importance. Chemical kinetics is basically a branch of chemistry that deals with the rate of a chemical reaction and definitely different factors that affects the rate. Okay, it helps us to determine the speed of or rate of a reaction and also like how the rates can be altered. Proceed. Next, one more numerical. The rate of a reaction quadruples when the temperature changes from 293 to 313 Kelvin. Calculate the energy of activation. Again, this is a type of Arrhenius equation you have to apply here. Let's proceed. Okay, so log K2, we can see the rate is quadrupled, right? So from here I can tell you K2 is basically 4 into K1. I am directly putting here 4 K1 divided by K1 equals to EA by 8.314 into 2.303 313 minus 293 divided by 293 into 313. Okay, so if you calculate this further, this is going to be log 2 square is equals to EA by 8.314 into 2.303. Here you will get 20 divided by 293 into 313. Now simply if you just calculate this thing, log 2 value is 0.301. EA is going to be 2 into 0.301 into 8.314 into 2.303 into 293 into 313 divided by 20. Okay, so this is the calculation. If you do this calculation, your answer should come like 52.8 kilojoule per mole. Okay, be careful about doing this calculation. Okay, let's proceed. Yes, okay, so this is a very important problem actually. The C14 content of an ancient piece of wood was found to have 3/10 of that of living tree. Calculate the age of that piece of wood. Fine. We can use the first order equation, first order rate equation only. So because any radioactive decay will follow first order equation, first order kinetic. 303 divided by lambda. Lambda is called as decay constant, log n0 by nt, right? So lambda we have to calculate because half-life is given. You can see lambda equals to 0.693 divided by T half, right? T half is given as 5730. Fine. Now they are saying that NT is equals to 3/10 of N0. So from here NT by N0 I can get 3/10. Okay, let's put everything here. So T is going to be 2.303 divided by 0.693 into 5730 into log 10/3 because not by NT, 10/3. Okay, so now if you just simply calculate, I'm not showing the detailed calculation here. You can break down log 10 minus log 3, okay, and you can put the value of log 3. Okay, if you calculate this, you will answer, your answer will be 9957 years. That is the answer. I guess this is clear to you. Yeah, let's proceed. Okay, for this particular problem, ROR, rate of reaction, is basically equals to -1/2 dA by dt equals to -1/3 dB by dt equals to -2 dC by dt. If you just multiply these two with everything, it will be something like minus dA by dt equals to -2/3 dB by dt equals to -4 dC by dt. So option A is going to be the correct one. I guess this is clear. Let's proceed. Derive the integrated rate equation for the zero order reaction. Okay, let's do it. So A gives you P. Let's say this is my equation. Okay, so rate in accordance to the differential rate equation, we can write minus dA by dt. This is your equation number 1. Next, R equals to, from the rate law you can write K into A power 0. Let it be your equation number 2. Equating these two, you will get dA by dt equals to minus K into A power 0. A power 0 means, you know, it's 1, right? So from here, if I just integrate by arranging a little bit, dA equals to minus K into integration of dt. So when t equals to 0, A is A0. Okay, when t equals to t, it is AT. Okay, now let's put the limit after doing the integration. So from here I will get AT minus A0 is basically equals to minus KT. From here K you will get A0 minus AT divided by T. That's it. Okay, I guess this is clear for you. Let's proceed. Okay, one more numerical problem here. You can see a first order reaction has rate constant this at 500 Kelvin, and at what temperature the rate constant becomes this, means T2 you have to calculate. Fine, let's do it. So log K2 by K1, let me directly write the, let me directly substitute the values because already I have written this equation for multiple times. So log K2 value is 17.25. 17.25 into 10 power minus 4 divided by 2.3 into 10 power minus 5, okay, equals to, EA value is given as kilojoule. We will convert it into joule. So 191478, okay, divided by 2.303 into 8.314 into T2 you have to calculate, right? So 1 by 500 minus 1 by T2, that's it. So if you calculate these portion, you will get log 75, okay? So log 75 is basically equals to, if you calculate this portion, this, you will get 10,000. Okay, 10,000 point something, I am just simplifying it to 10,000, okay, divided by, into 1 by 500 minus 1 by T2. Okay, now log 75 if you calculate, you will get 1.87. Okay, equals to, if I just simplify, 10,000 by 500 Kelvin minus 10,000 by T2. So by simplifying, I am not going to further simplification, you can do this I guess from here. T2 you will get something 551.57 Kelvin. Okay, I guess this is clear to you. Let's proceed. Okay, a first order reaction has half-life 23 minutes. How much time will be needed for 30% completion of the reaction? Fine. So let's calculate K from the half-life, that is equals to 0.693 divided by 23. It's going to be something like 0.0301 minute inverse, right? Okay, now here you can see 80 means after 30% completion you will get 70% left over of A naught, from here 0.7 of A naught, right? So if you just put it into the first order integrated rate equation, that is T equals to 2.303 divided by 0.0301 log A naught by 0.7 of A naught. Okay, just simplify this, everything will be cancelled out here, A naught will be cancelled out here. T, if you calculate further, you will get your answer as 11.84 minute. That is your answer. Okay, I guess this is clear to you. Let's proceed further. Little bit we will do from question bank. Okay, again I am telling you, this type of question I already solved. Initial rate method, develop 3 different equation and then solve it out for x and y, you will get it. Okay, let's proceed further. Okay, for a first order reaction, plot the graph of log R0 versus R versus time. Okay, so how you should do, you know, if I show you from this step, integration of d of A by A naught to AT is equals to minus k into integration of t equals to 0 to t. Okay, if I show it from here, that is ln of AT minus ln of A0 equals to minus kt. Fine. Now if I convert it to log and also alter the sign, I will get 2.303 log A naught by AT. I altered the sign, okay. A naught by AT, here I am getting KT, right. So now if I just change the side, log A naught by AT is basically equals to k by 2.303 into t plus I can write 0. So this is your y, right? This is your m, this is your x, this is your intercept. 0 intercept means it is passing through origin, right? So let's plot the graph. So I am having log A naught versus AT at the x-axis. This is t, okay. It will pass through origin, and the slope value you can write from the equation itself, that is k by 2.303. I guess this is clear to you. Let's proceed. Okay, what happens to the half-life time of a first order reaction when the temperature is increased? So basically half-life of a reaction will decrease as the temperature is increased. Okay, why? Because temperature is directly proportional to rate constant. If you increase temperature, rate constant will increase, and half-life is inversely proportional to rate constant, and hence half-life will decrease. I guess it's clear. let's proceed. This is the plot of Maxwell-Boltzmann curve, and this particular point after which the molecule will take part in the reaction, that is the activation energy. Okay, I guess this is clear. Let's proceed. Illustrate the graphically the effect of catalyst on activation energy. You have to draw this graph. You have to mention that initially the activation energy was this much, but after adding the catalyst, the dotted line represents the path on being added with the catalyst. So as you can see, activation energy will be reduced. Proceed. Graphically represent the Arrhenius equation. Here you can see ln k versus 1 by t we can represent, and slope we can calculate. From the slope we can calculate the energy of activation, because slope value is minus A by R. Okay. Let's proceed. Derive integrated rate equation for the first order reaction. Okay, let's do it. A gives you the product. Okay, so from here R equals to minus dA by dt. This is your equation number 1. Next, R equals to, from the rate law, I can write k into a power 1. Okay, this is equation number 2. This 2 can be, if we equate equation 1 and 2, so minus dA by dt will be equals to k of a. If we rearrange and do the integration, you can do it in different step. So integration of d of a by a equals to minus k into integration of dt. So here it is a0 to at if I put the limit, and here it is t equals to 0 to t equals to t, right? So from here further I can move towards this. If I just do the integration, ln of at minus ln of a naught is equals to minus kt. If I just alter the sign and do the log, converting into log, so it will be 2.303 into log a naught by at is equals to kt. So yes, from here I can come up with k equals to 2.303 divided by t log of a naught by at. This is the equation. Okay, I guess this is clear to you. Let's proceed. Okay, what is the effect of catalyst on the reaction with respect to activation energy? So positive catalyst, definitely it reduces the activation energy and it makes the reaction rate faster, and delta G, it has no role with the delta G. Okay, let's proceed. If a homologous catalytic reaction can take place through 3 alternative paths as depicted below, the catalytic efficiency of PQR. So definitely, as you can see, P is having more activation energy, right? So it will take more time, then Q, then R. So whenever I am using R as a catalyst, the reaction will be fastest. After that Q, then P. Okay, let's proceed. Okay, so here comes the next one MCQ. Consider the following statement with respect to zero order reaction. The rate of the reaction is independent of reactant concentration. Definitely it is true. Next, the rate of the reaction independent of a temperature. No, it's not true. Next, rate law expression, the unit of K is S power 1. No. Next is the rate constant of reaction is independent of reactant concentration. Yes, that is true. So option D is going to be the correct one. Let's proceed. A first order reaction, the time required for 99.99% reaction to take place is nearly 10 times than that of the half-life of the reaction. Okay, let's proceed further. When the initial concentration of the reactant is doubled, the half-life period. Okay, let's do it. So they are saying, let's say T half-life, it is 1, that is A0 by 2K. Now we will just double the initial concentration. So T half-life 2 on doubling. So 2 of A0 by 2K. So don't you think it's nothing but the 2 times of T of T half 1, right? So it will be doubled. Okay, I guess this is clear. Let's proceed. Okay, in collision theory, the chemical reaction ZAB, it represents the fraction of molecule that is having the activation, the energy more than that of the activation energy. Okay, so option B is going to the correct one, that fraction of molecules with energies greater than EA. Proceed. For the reaction, enthalpy of reaction is minus 4.2 kilojoule per mole and enthalpy of the activation is 9.6 kilojoule per mole. The correct potential energy profile. Okay, nothing you have to see, just look at the sign. Negative sign represents the exothermic reaction. So these particular graph represent the exothermic reaction. Okay, let's proceed. Okay, more numerical problem we will proceed with. In a chemical reaction, A plus B gives C plus D. The concentration of the reactant A alone is increased by 2 times. The rate is increased by 4 times. Okay, one by one we are going to write. Here also you have to develop the equation. So let's say R1 is equals to K into R, normal R also you can take actually, A power X into B power Y. This is your equation number 1. Okay, so first condition what they are saying, reactant K they are doubling 2 times, they are doubling, right, and B they are keeping constant, the reaction rate will increase 4 times, so 4 of R. This is equation number 2. Another one they are saying that if concentration of both A and B increased by 2 times, so K into 2A power X 2B power Y, right, this is equation number 3. Okay, the rate is 8 times. Okay, okay, now we have to solve this equation to get X and Y value. So what I can do is 3 divided by 2 I can do, 3 divided by 2. So here 8R divided by 4R is going to be 2A, K is also there, 2A power X into 2B power Y divided by K into 2A power X into B power Y, right. From here what you can get is 2 equals to 2 power Y. From here I can get Y equals to 1. Fine. Now solve for X. What I should do? I can do 2 divided by 1. If I do 2 divided by 1, so 4R divided by R is basically equals to K into 2A power X into B power Y divided by K into A power X into B power Y, right. From here I am getting 4 equals to 2 power X, so I can write X equals to 2, right. So overall order, if I want to write further, R equals to K into A power 2 B power 1. It is second order with respect to A and first order with respect to B. I guess this is clear to you. Let's proceed. Calculate the time in seconds for the decomposition of nitrogen pentoxide which follows first order kinetics when concentration of N2O5 is dropped from 0.1 molar to 0.01 molar. Okay, it's very easy basically. First order kinetics we can use 2.303 divided by K into log A0 by 80, right. Everything just you have to put the value and calculate. 2.303 divided by 6.2 into 10 power minus 4, it's given already, log, it started from 0.1 and it dropped to 0.01. So if you just simply calculate, you will get the answer. Okay, I'm just directly going to the answer. You will get as 3.7 into 10 cube second. Okay, I guess this is clear to you. Let's proceed. Okay, so for a first order reaction, show that the time required for 99% completion is twice the time required to the completion of 90% reaction. Fine, let's do it. So T of 90%, let's do, that is 2.303 divided by T log A0 is 100 90% completed means AT is 10. Right. From here I can write 2.303 by K into log 10. That's it. Next I can do, this is T of 90%. Okay. Next I can do T of 99%. Okay. That is 2.303 divided by K log of A0 A0 by 0.01 basically, because 1 by 100, right, into A0. Okay, so if I further do this, T99% will give you 2.303 by K into log 10 square. Okay, from here I can write T99% is basically 2 times of 2.303 divided by K into log 10. Okay, so what is this? This is nothing but T90, right? So T99% is basically 2 times of T90%. Proved. Okay, I guess this is clear to you. Yeah, let's proceed. T half of a reaction is 10 minutes. For a first order reaction, what % of reactant remain unreacted at the end of 50 minutes? Okay, so number of half-life. Number of half-life, how I should get it is basically, let it be N. Okay, that is basically T by T half. Okay, total time is how much? End is 50 minutes, right? 50 divided by 10 minutes, that is 5. Okay, now fraction of the reactant. Fraction of reactant remaining after n half-life, there is a formula, it's going to be half power n, right? Half power n, remember this. Okay, so from there percentage how I should get, that is half of n, half power n into 100%. Okay, so let's put half power 5 into 100%. Okay, so from here we will get 1 by 32, right? 1 by 32 into 100%. So you will get here 3.125%. Okay, so this is the process. Let's proceed. Yes. Okay, the graph of log K versus 1 by T for reaction is linear with intercept 10 and slope given. Okay, calculate the frequency factor and the EA. Okay, so it is basically Arrhenius graph. Okay, Arrhenius graph value, I guess you know, if I just write down the equation, log K equals to log A minus EA by 2.303 R into 1 by T, right? So from here what they are asking, log A is given as 10. Log A is the intercept. Okay, it is given as 10. From here if I find out A, that is going to be 10 power 10. That's it. Okay, next slope. Calculate the frequency factor, we have to calculate, and EA as well. Okay, so slope we are having from this straight line equation, slope we are having minus EA by 2.303 R. Slope value is given as minus 5.1 into 10 cube. So let's multiply into 2.303 into 8.314, that is equals to EA. So EA, your activation energy is going to be how much? It's going to be 97.650 kilojoule per mole. Okay, I guess it's clear to you. Yeah, let's proceed further. This is your frequency factor, this is your activation energy. Okay, let's proceed. Okay, so that's it. So here comes the end of the entire physical chemistry. So I guess you understood what type of problem can come and which formulas you have to focus for the numerical purpose. A lot of numericals we did here. If you do this, I guarantee 65 plus marks in your chemistry examination. So yes, without further delay, don't forget to like the session. If you have not subscribed, then please subscribe and share this video with your friends so that they can also get the benefits of this video. Thank you so much for watching.